Hello everyone, welcome back to our next lesson. We're going to continue with hyperbolas in this video, and right now we're on page 28 in your textbook. So I'll get you to turn to page 28, and it starts with example number 2 on the top of that page. And what you're asked to do here in example number 2 for question number 1 is to sketch the given hyperbola. There's an equation of a hyperbola right there. Um, Really, we've gone over this in the previous video, in the previous lesson. Number 2 is also basically the same thing to sketch a hyperbola. I tell you what, I think I'll do example number 2 here with you very quickly, just to show you how simple this is to sketch a hyperbola. Drawing the hyperbola is easy. Um, all we need to do is determine the direction that it's opening, get our center, and get our vertices and co-vertices, and also the foci as well. All right. Now, by the way, remember I was talking about the asymptotes, coming up with the equations of the asymptotes. What if this was a question on a test or on a quiz that you had? And what if the only thing you had to do here for this equation, number 2, was to come up with the equations of the asymptotes? Well, remember I showed you a real simple way that you could do this. Um, you know that your asymptotes are straight lines. It's going to start with y minus 2. Y minus 2 equals, all right? So you don't need to change that at all. And the reason that these x minus h and y minus k don't change is because the center of your hyperbola is exactly where these two asymptotes are going to intersect anyway. All right, and so that's why these terms don't change. Now you're going to have plus and you're going to have minus. These are your two slopes now, all right? And remember the way I showed you to do this, the easiest way, is to first of all look at the number that's under the y term. And there it is right there, it's 4. Now in this case, it's your a squared. It doesn't always have to be the a squared, but in this case it is. So if you take the square root of 4, you're going to get a 2. That is going to be the numerator of your slopes for your asymptotes. Now look at the number under the x, and in this case it's a 16. If you take the square root of that number, you're going to get 4. Well, by golly, that's going to be the slopes of your two asymptotes, and in fact, that can reduce. Now, you always should reduce a fraction if possible. So look at what we have. We have 1/2 as our two slopes of the asymptotes, and now behind that, I just place the x plus 1 as well. And look at that. Now remember, the y minus 2 and the x plus 1, sorry, neither one of those becomes squared. If you squared either one of those terms, you don't have straight lines anymore. So like I said, getting the equations of the asymptotes is actually pretty straightforward. All right, so what I'll do now, I'll just erase all this. I'll leave that there. I'll leave the asymptotes up there because we can come back and look after we draw the asymptotes just to verify that that's actually what their equations are. All right, so here's what we do now. Here's how I would start this. First of all, I would determine where the center of this hyperbola is located. And in fact, now you look at what's behind the x first. You always look at what's behind the x. We have x plus 1, so your center is going to start with a minus 1. And then you look at what's after the y, and here we have a y subtract 2. Negative 2, change that sign, it becomes positive 2, and there, ladies and gentlemen, look at that. There's your center. All right, so we should show the calculations as well. Don't just draw the graph. You have to show your workings. You have to show your calculations. So negative 1 and 2, everybody, is right there approximately. That's as good as I can graph it with my old stylus that I'm using. All right. And the next thing I'm going to note is that in this equation, it's the y squared that's positive. All right, meaning that this hyperbola will definitely intersect the y axis somewhere in two places, but it may not intersect the x. And what that means is kind of it opens up and down like that. Your center is going to be right in between, And in order to get your vertices, you have to go up and down, in this case, from the center. And that involves my a squared. So a squared, remember, for a hyperbola is not necessarily the bigger number. It's the number that's under the positive term, the denominator of the positive term. I think in your notes they say that it's the first number, the first denominator, which is true. If it makes sense if you say that, because typically we would write the positive term first, all right? And that makes sense. So here we go. We got a squared is equal to 4. Take your square root of both sides. You get a equals 2. And that tells me now how far that I have to go up from the center and down from the center, up 2, and down 2. So there's one vertex and there's my other vertex. I like to write little v's beside that. So here's my 2 vertices, and you can just read the coordinates now off from the graph, you see. So one is going to be at -1 and 0, and the other vertex is going to be at -1 and 4. There's your 2 vertices, and we've got those graphed already. We have those plotted. Now we'll get the covertices, and that involves the b squared, because we need our b, you see. Now b squared is under the negative term, so there's my b squared right there. It's 16. Now notice this time it's the bigger number, isn't it? Well, that can happen. That can happen for a hyperbola. It's, as I mentioned before, it's even possible for a hyperbola to have the a squared and the b squared being the same number, the same value. All that means is that when you draw your box, that rectangle, to get your asymptotes, all it means is that you actually will get a square in that case, not just a rectangle. Anyway, I get b equals 4. So this will give me my covertices. And again, so if you look up here, I got to go 4 to the left and 4 to the right of my center. You could put that right in your graph right now. 1, 2, 3, 4. Okay, so there's one covertex approximately, and 1, 2, 3, 4 blocks the other way. There's my other covertex. Now remember, you know what? You could draw this right now. So my covertices would be, let me see, one is going to be at -5 and 2, and the other covertex on the other side is at +3 and 2. There's my 2 covertices. Okay, so now you take a ruler. Remember what you do. You draw a box. You could work out your foci first if you wanted to and plot those first. I'll tell you, one of the bigger mistakes I've seen, one of the more common errors, is that after a student puts in their foci, if they haven't drawn the graph first, a lot of students will actually draw the graph going through the foci instead of the vertices, which of course is incorrect. All right, let's see. What will this become? One side is, now remember, I'm just roughing this. These lines are not straight. You use a straight edge. One side kind of like that, and the other side kind of like that. Now there's your asymptotes, you see? You look at that carefully. Now if I had drawn this either bit accurate, you'd definitely be able to tell, look, that your slopes are, one is +1/2 and the other one is -1/2. And they both go through the point -1 and +2. All right, so now here we go. Here's your hyperbola. One side, kind of like that, getting closer and closer to that asymptote, remember? There's the other side, something like that. And down below, one side and the other side. And there you go. Your graph is drawn already. Now we do need the foci, yes. So let me see. C squared is equal to a squared plus b squared for hyperbola. So in our case, you're going to get 4 plus 16. That's your a squared and your b squared. So you're going to get 20. All right, that's equal to 20. So c squared is c. I'll just get the square out of there now. So c is actually equal to the square root of 20. You could leave it as a radical, 2 root 5. Or if you wanted to write that as a decimal, let me see, what should that? It should be about 4.5. Let me say square root of 20. Yeah, 4.47. So you can call that 4.5. All right, so again, I have to go up and down 4.5 units. from the center. 1, 2, 3, 4, 4.5. Now, yeah, there's one focus way up there. And 1, 2, 3, 4, 4.5 blocks down the other way. There's my other focus down there. And write down the coordinates as well. One would be at -1 and approximately -2.5, and the other one would be at -1 and approximately 6.5, 6.5. All right, and that one is done. We've sketched the hyperbola. We've included everything, including the two foci. Yours is just going to look a lot neater than mine because, like I say, I don't have a ruler. Let's look at number 3. Number 3 is a little different. It's a little different because this time they're not giving you the equation. All right. Now we can come up with the equation. Quite possible they could give us this information and say, what is the equation of your hyperbola? Let's see. What are we going to do? Why don't we take our graph paper and actually, as much as we can anyway, plot those things that they're giving us there in number 3. So the center is at 1 and -4. Let's go ahead. I'm going to plot that center right there, approximately. There's where 1 and -4 is located. And they're telling me that a focus is at the point 1 and 1. Well, that would be right there. Okay, let me see if I can plot that. There's my focus right there, approximately. I can't get this. All right, so let me put a little F there beside that. That's my focus. And there's my center down below. Now that, ladies and gentlemen, that's going to give you your distance, C, isn't it? Because the distance from the center to the focus is what we're calling C. And in fact, if you wanted to, you could even go down 5 blocks the other way. In fact, we should go down 5 blocks the other way. And there is that's the second focus. All right, that's the second focus. Now, what else do we have? Okay, we've got that done. We've got that done. Then it says that the transverse axis is 8 units long. And what you need to remember is that the transverse axis is the one that joins your two vertices together, right? It's kind of like the major axis was in an ellipse. So what you're going to do, and in this case, I can clearly tell that my hyperbolas are going to open up and down, meaning that the y squared is going to be the positive part and the x squared is going to be the negative part. And because it opens up and down, then my two vertices are also on that same vertical line, that transverse axis. Okay, so from the center, I go up 4, and I also go down 4. Now remember, this 8 units long, that means that 2a is equal to 8, right? So I get my a is equal to 4. Half and half up and half down. And there's my other vertex right there. I'll put a V there and a V there. Now, if I had a better stylus, you'd see this a lot better. Now, what am I missing? What am I missing? Well, I'm missing my co-vertices, right? I'm missing that B. I'm missing my co-vertices. Well, I can easily calculate my co-vertices, though, because from the diagram, I can clearly see that the distance from the center to either one of the foci is 5. So my C is 5, which means that C squared is going to be 25. And now I'll just use that equation that relates A, B, and C. So I'll have C squared equals A squared plus B squared. Now remember, it's the B squared we're trying to calculate. You can bring the A squared to the other side first if you like. So that would be C squared minus A squared is equal to B squared. And C squared, look at that, 25 minus, there's my A. A is 4, so A squared is actually 16, isn't it? And look at that. You're going to end up with a nice number. You're going to get a nice number. That's 9. They're not all that nice, remember. So B in this case is actually equal to 3. B is actually equal to 3. So that means that because this hyperbola opens upward and downward, my co-vertices would be left and right from that center. So I go 3 to the right, and I get that point there. That's one co-vertex. I go 3 to the left, and I get 1, 2, 3. Let me see, about right there. That's my other co-vertex. Can't see that one very well. CV, CV. And now I'll draw my box. Remember, don't draw your box, your rectangle. not through the foci. It goes to the co-vertices and the vertices. So here's what the box actually looks like. That's a common error. All right, and that's why I usually don't draw the foci until after I get the box already drawn. So there's the box kind of thing. And now you can draw your two asymptotes. One would look something like that. I usually use a dash line. There's one. The other one. Now remember, I'm just roughing this. There's one side. And there's the other side. And now you draw your curve through your two vertices. There's one side. There's the piece opening up. And the piece opening down. Remember now, through the vertices, not through the foci. Something like that. That's kind of rough there, but and that's what it looks like. Now notice I didn't write down the coordinates of my foci and my vertices and my co-vertices over here. It didn't really ask me to. It is a good idea though if you write those things down. Now I got a question for you. All right, all them workings, all that graph. Now you tell me, what's the equation of that hyperbola? What's the equation of it? That could have been another thing I could have asked you. Say, instead of sketch the hyperbola, I could have said, what's the equation of the hyperbola? With a center at 1, -4, focus at 1, 1, and a transverse axis 8 units long. Well, I tell you what, let me erase some of this now to kind of clear up a little bit of room. Let me clear up a little bit of room here. Now, I'll remember, though, that my b is equal to 3. I'm going to need that. Let me just jot that up here somewhere. B is equal to 3. So remember, I need a squared and b squared in my equation, all right? Okay, now, first of all, notice that the center is at 1 and -4. So, of course, the 1 is going to come after the x minus 1. The -4 is going to come after the y, so that's going to be a y plus 4. They're both going to be squared. And because this hyperbola opens up and down, it's the y squared that's positive. So your equation is going to start y plus 4 squared over something. And it's going to be the positive term. Then you're going to have your minus, and then you're going to have x minus 1 squared. Don't forget the squareds. And you know it's going to equal 1. And now you just got to put your a squared and your b squared in the correct places. Well, the a squared obviously goes under the positive term, which in this case is your y squared. Here's your a. It's just 4. So, ladies and gentlemen, how about you put a squared there under your y squared? And now the b squared goes under the negative term. So there's your b. B is 3. So I guess b squared would be a 9. And there you go. There's the equation. Now that wasn't difficult at all, right? That wasn't difficult at all. We're going to look at another example now on the top of page 29. Now this is the one I told you in a previous class that they've got an error made here. So I want you to erase or cross out the 0,4 for the focus, and I want you to use 0,6. So at least now it's solvable. Okay, at least now we can actually come up with the answer here. So what we're going to do is just make a rough graph sketch, basically. And so let's see what we're going to do. Let me make a set of axes over here. And remember, this is just an aid to help me come up with the answer. Like on a lot of tests and quizzes, I actually give a piece of graph paper there. Not because you have to graph it, because the graph would help you or come up with the actual answer for an equation. Now, what are we told? We're told that the vertex is at 0 and -1. So that would kind of be down there somewhere, something like that. There's a vertex at 0, -1. I wish I had a better stylus. There's your vertex, something like that. Now I'm telling you that the focus is at 0 and 6. Well, that's kind of up above here. Ah, this one opens upward. Look at that. So your focus is approximately there, and that's at 0 and 6. So I've got a vertex, and I've got a focus. Now notice where you're told the center is. It's at 0 and 2. So it would kind of be up 2 blocks, up to approximately there. but there's your center. See that? Oh, you see. Now that's not the same as the distance from the vertex to the focus. See though, I shouldn't probably use C to be honest with you. So that's 0, 2. Okay. Now there's what we've got, everybody. There is what we've got. Now I can tell it opens up and down. So the y squared is going to be your positive term. The center is right at 0 and 2, right there. Okay, I'll just make sure we see that. So you're going to have just x squared, and you're going to have y minus 2 squared. And the y is going to come first. Look at that. You're going to have a y minus 2. Already, even before I do any workings, I've got a really good idea what this is going to look like. And that's going to be just x squared. And now you know it's going to equal 1. You always get them equal to 1. Now look, if you can look at that little simple diagram that we've drawn there, I can see the distance from the center to the vertex right there. Well, that is my A, isn't it? So from negative 1 up to positive 2, everybody, that's a 3. So A is 3. And I guess that means that A squared is going to be a 9. And that's got to go in under the Y because it's opening up and down. Look at that. You're missing one number and then you're done. Just one number missing. Okay, so what do we do to get that missing number? Well, remember now, the distance from the center to the focus, that is my C. And from what I can tell in that diagram, it looks to my old eye, like C is equal to 4, isn't it? From 0, 2 up to 0, 6. Now that's why the original 0, 4 didn't work, by the way. It was too close. It was actually closer to the center than the vertex was, and that would not have worked. Well, if C is 4, then I guess C squared is going to equal 16, isn't it? And now I just use that very simple formula, C squared equals A squared plus B squared. That's what it is for a hyperbola. And so you're going to have 16 is equal to, you could even get the B squared by itself first if you want. And that's a 9 plus B squared. And throw your 9 over with the 16, it becomes a negative. And look at that. B squared is equal to 7. Now, if you were trying to find the coordinates of your covertices, well, of course, you'd have to take the square root of that. But that's not what we're doing. We just have to find the equation of the hyperbola. And we've got the B squared. B squared is what actually goes in my equation. So I just got to kind of come up here to my equation and put a 7 right there. And I'm done. We've got this one finished. Now, wasn't that easy? Wasn't that straightforward? And it all came from making a few simple observations of what the graph must look like and which way it's opening. All right? And like I say, if this was a test or a quiz, usually I would give a blank piece of graph paper and say, here you go, you use this now to actually help you figure out what the answer is. All right? But that, everybody, there's your answer for number 4. Now, number 5 and under that. That one is a doozy. Now, you can try it. I might try it in class. I may go over it as an example. I just want to explain what you've got to do here. This one says, find the equation of the hyperbola with the asymptotes. Oh, now look at this. They're actually giving you the two asymptotes. All right, so one's kind of like that, and the other one's kind of like that, but you don't know where they intersect, do you? And you're told where one of the vertices are. So the vertices is either to the left or to the right or above or below the center, which is right there where they intersect. Wait a minute, where they intersect. You know how to get where they intersect, don't you? You did that back at Math 1700. Solve the system of equations x minus y equals -1 and x plus y equals -3. Find out what your point is. Find your x and your y, your solution to that system. And whatever that x, y is, that's the point right there where they intersect each other. Okay? So now, if you had a piece of graph paper, you could plot that center. You could plot this vertex. You can easily tell which direction that this hyperbola is going to open in. There's a little more to it than that, though. And I may go over it in class with you. So what else do we have after that? Okay, just the practice problems. This begins on page 30. This says graph each hyperbola. They look fairly straightforward. I don't think you'll have any difficulty with any of those. And just keep checking your answers with D2L. And then on page 31, you have a bunch of problems where you have to get the equation of a hyperbola given the various pieces of information. All right, now be careful with C. Look at that. That's the exact formula. You see that right there? I can look at this. I can see where my center is. My center is at 3, -9. 3, -9, 3, -9, because these things are being added and subtracted. And because it's the foci, that means you're adding and subtracting the C. You see that? Well, that I know one thing. My C is √145. Because to get from the center to the foci, that's what you'd have to do. And there's my 2 vertices. Oh yeah, that's not too bad now if you do that. So try that one as well. And that's where we'll stop. That's where I'll get you to finish up with the practice questions. So when we come back in our next class, I'm going to very quickly look at page 32, and that's not going to take us very long. And then we'll start that. Okay? So I'll end there. Thank you very much. Have yourselves a great day. Bye-bye.